Okay. Sean just turned 25 years old and graduated from college. He plans to deposit $200 into an IRA. That's a type of retirement account at the end of each month until he retires at the age of 60. Answer the following questions based on an interest rate of 4.6% compounding monthly. Round to the nearest cent as necessary. All right, so we have an interest rate of 4.6 and we are compounding slash paying monthly, so 12 payments per year. Now, I do need to know how many years this is for. So we are going to have to do a little bit of math. Not too challenging. He's going to retire at age 60 and he's currently 25, and so that would be for 35 years. So when I go into N, I'm going to type 35 times 12. Again, this is another one where I don't have a present value, but I do have a regular payment amount. He's putting in $200. And how much will Sean, I know I need to sort of fix this, Sean have when he retires. So I'm looking for a future value. We're basically being asked the same few questions we were asked last time, which is, I think why the U is still there. So I'm just going to write Sean here. So we have deposited and we have interest. Okay, so let's go type stuff into our calculator. So we have N, 35 times 12, and so that says 420 payments. 4.6 is our interest rate. We have no present value, but we are putting in $200 each month, and we're going to be doing that 12 times a year. I like to just click on the C/Y box just to make sure that it carries down, and I'm going to solve for my future value. Ooh, so we have dun, 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 208,040 point. Oh no, what is the point? And notice it didn't pull up for me, so I'm going to hit that random button so I can see the rest of my number. Such a helpful trick. All right, so how much money is deposited? Remember, the key here is payment times number. Um, our number is 420 payments of $200. And when I figure that out, that's $84,000. So this time around, yeah, he deposited a lot of money, but he's going to have earned quite a bit of money in interest or his net gain. So we're going to take that end amount. Another way to think about this is sort of it's like your absolute change. Huh, some things, they're just all interconnected. Isn't that so fun about math? All right, so I take my new value and I subtract the original amount deposited, even though it was deposited over a time period. And we find out that he earned $124,000 and $40.16 by just putting his money in a bank account. That's pretty nifty. All right, I'm going to clear out my TVM solver. Oops, doesn't want to clear, so I had to click it a few times. And now we're going to talk about Paula. So Paula is investing $5,000 in an account that earns 4.1% interest compounded quarterly. And we want to know how much money she's going to have in 25 years. This is your stereotypical compound interest problem. And you could plug this into the compound interest formula, or we could just interpret where it would go in our TVM solver and use our time value money calculator. So we have our interest rate. I like to start there. It's always the easiest one to record, 4.1%. $5,000. So this is a lump sum. We're not told that she's putting in more money, so I'm just going to have my one-time payment, um, not a regular payment. We want to know how much money she's going to have in 25 years. It's quarterly. So quarterly is 4 times per year our interest is paid. And so I want to know how much money she'll have in 25 years. So 25 times 4 times the number of times that, either compounds or the payments you make in a year. So 25 times 4, 4.1, negative 5,000, because we don't have that money in our bank account. Well, we don't have it in our pocket anymore. And I want to solve for my future value. And she earns $13,862.96. All right, last but not least, how long does Mariah need to save if she wants to retire with $1 million? Ooh, $1 million. If I had $1 million. Okay, sorry. Whenever I hear that, that's what I think the Bare Naked Lady song. All right, so Mariah needs to save if she wants to retire with $1 million, and she saves 5,500 a year at 5% interest. And I got this because back a few years ago, it's gone up now. That used to be the max you could contribute to your retirement account each year. Now it's a little higher. But we'll go back to the old number. So she has 5% interest. She has zero for her present value. She's going to pay out 5,500 each year. And she wants $1 million. So that's 6 zeros. And she's paying out once per year. And we want to know how long would it take her. So in this case, we don't know the end value. We know our interest rate is 5. Her present value is 0 because she's contributing, oops, 5,500, and she wants $1 million. Always double check you have enough zeros. 1, 2, 3, 4, 5, 6. You know, I get sort of like, did I do enough? And we're paying out once per year. And we are solving for n this time. And so n comes out as 47.38. Now, keep in mind, n is measured in whatever this value's unit is, the p per y. And in this case, this is yearly. And so that means this is years. So it's going to take her 47.38 years. But here's the thing. The interest only gets applied at the end of each year. So we'd actually say it'll take her 48 years. We'd round it. She won't have $1 million yet in 47. And so at the end of the year, it would be 48 years. All right, stay tuned for the next video to watch some more fun TVM Solver savings practice.